So our project is on the Raspberry Pi cluster. We created a cluster computer consisting of these small embedded systems called Raspberry Pis. Um, so we're, we're going to go through the context and what it's used for, cluster computers, the hardware we used, the software we used, and how we made it, and our future plans to with moving on with this project. So our first off, today we use cloud computing like there's no tomorrow. We have people using clusters to crunch large amounts of data, and it's very practical for us as users, just with memory and storage and applications. But now we have, for us, the biggest thing is learning and using platforms to learn off of those. Because how do we go into industry not knowing how to use cluster computers, and all of a sudden we have that problem? We need to use these things. So it's to better learn how a cluster works and how to make one, basically. So the hardware we used was basically these small devices called Raspberry Pis. They are embedded systems. Along with that, we used a network switch to help interconnect them and provide a network so they can communicate back and forth. We had power supplies for each one so that each one had its own individual power. And we also had just the network cables that we connected them to the router and whatnot. So for communication, we basically followed one of these guides. And to start off with, we used, because of our lack of knowledge of how to make clusters, we used a software called OpenMPI, which basically passes messages back and forth to the Raspberry Pis. We use the OS, the base OS that most people use for Raspberry Pi, which is Raspbian OS, and we use Python basically for programming uses to try to learn and communicate with it. So that leads into how we made it. Since we use Linux-based software, we could basically edit any network information. So since it was so easy to, send information, we basically set up a secure shell connection, basically an SSH connection, so that we could exchange information. And we based it. So one Raspberry Pi was the head node. It was in charge of sending and distributing the information. The others were basically slave nodes. They did what the head node told them to, and they just reported back their information. And the way we did this was by use of the MPI software. The MPI software allowed us to pass those information over the internet, over the network that we had created via, this could be a switch, but we used just a router that we got at Goodwill, and it's basically exchange information and reported back. So if we wanted all the host names, basically the names of the Raspberry Pis, each one, it would send out, hey, run this file on your system, and then report back what it said, and it would display it on just the head node's display. So this is really practical for us learning how Raspberry Pis just work and how information works in general, and how to program on that. And we want to expand farther with this. So for our future plans, we want to expand the amount of Raspberry Pis we have. Currently, since we only use 4 Raspberry Pis, we would like to expand it to 16, which we plan to next semester actually, and and to make this thing more powerful, and even maybe 120 someday. There is no really guarantee of how it was basically based off of what this next project's going to be, the 16. Um, After that, we want to create more efficient programs for the Raspberry Pis and the cluster, making it easier to communicate with each other, making it so a standard user could say run a script on one and it would automatically do it for all the others and run it simultaneously. Along with even to the point where we want maybe even programming a language specified for cluster computing, which would be amazing for us. So in the end, we hope to expand this project into the future and just understand basically understand how far we can go and how to program on all of this, on these clusters, because it's such used in industry, and we would just want to be able to learn more about it. And that is it.